So now we're kind of getting to the business end of chapter 3, and what we're going to look at now is what is the process by which bonds form within ionic compounds. This type of bonding is called ionic bonding. It's the bonding that exists between positive and negative ions in ionic compounds. Now, the key to understanding the formation of an ionic compound is to recognize that electron loss from a metal atom to form a cation occurs simultaneously with electron gain of a nonmetal to form an anion. So the classic ionic compound is sodium chloride. And you can see what happens. Here's the sodium atom. It's got 11 electrons. And in the third shell, it's got 1 electron in a 3s subshell. So the electron configuration, 1s2, 2s2, 2p6, 3s1. Now here's a chlorine atom, and chlorine has 17 electrons, and it has this electron configuration, 1s2, 2s2, 2p6, 3s2, 3p5. So what you can see is that there is a possibility for a chlorine atom to take on another electron and complete this p subshell. And furthermore, a sodium atom would love to give up 1 electron, so then it has a noble gas configuration of 10 electrons, just like neon. So this is what's going to happen, is an electron is lost by the sodium atom and gained by the chlorine atom, and that occurs just like simultaneously. It's a transfer, right? Electron transfer happens, and what we end up with is a sodium cation. It's +1 because it lost 1 electron, with 10 electrons in the configuration that neon has, and then we end up with a chloride anion with 18 electrons with the same electron configuration as argon. So by transferring this electron, both of our atoms obtain a noble gas configuration. But what happens is that the sodium atom has become positively charged and the chlorine atom has become negatively charged, and now they're going to attract one another and get stuck together. So while both atoms do obtain a noble gas configuration, there's a price to pay for this. They're now stuck to one another, and that's what an ionic bond is. So the attraction between ions formed as a result of electron transfer is called an ionic bond. So the take-home message here is that electron loss by a metal and electron gain by a nonmetal occur concurrently. These two atoms are near one another. The ions that get formed will attract one another because they are oppositely charged, and that will result in the formation of what we call an ionic bond. And you can illustrate this transfer of electrons and formation of ionic compounds using Lewis structures that we learned about earlier. So here's a lithium atom. It's in group 1a, so it has 1 valence electron, and here's a chlorine atom. It's in group 7a, so it has 7 valence electrons. And what happens? An electron moves from the lithium to the chlorine. This results in the formation of a lithium ion, which we've indicated here by putting a plus sign there, and then a chloride ion, which has 1 minus because there was 1 electron that was gained, that has a complete outer shell. Now people commonly put an extra arrow here and then just write the formula for the ionic compound that forms. So it's a pretty simple idea. You should be able to use Lewis symbols, or what are sometimes called Lewis structures, to illustrate this transfer of electrons in the formation of an ionic compound. So something to keep in mind when you're doing these diagrams is to recognize that the metal will lose all of its outer shell electrons. Okay, so you'll see here after the transfer there are no electrons left around the metal. The non-metal atom, however, will always complete its outer shell and will always end up with 8 dots around it. Okay, so by doing this transfer, what do we see? the metal obtains the noble gas configuration of helium, and the non-metal, and I should have put this in here before, the non-metal ends up with the electron configuration of argon. So something to keep in mind when you are doing these diagrams, you always write the metal ion on the left, just as it appears in the periodic table. And something that can happen is that you require more than one of the ions. So I'll do a few examples where we have more than one of the ions now. So magnesium is in group 2A, so it has 2 dots around it, and chlorine is in group 7A. So you can see that the magnesium would like to lose 2 electrons and the chlorine would like to gain 2 electrons, because the metal always ends up with no dots around it and the non-metal always ends up with a full set of 8. So where this leads us is that we need 2 chlorine atoms to write this structure correctly, and there we are, magnesium lost 2, and then we have 2 chloride ions with their complete octets. They each gained 1 electron. So they have a negative charge, and then we might finish this off by writing MgCl2. So this is what I'm talking about here. You might have to stack one or more atoms and ions on top of each other in order to write out correctly how the electron transfer occurs. So keep that in mind. Okay, so the type of ionic compounds that we're interested in this chapter are what are referred to as binary ionic compounds. And in binary ionic compounds, you have one kind of cation and one kind of anion. Now, that doesn't mean that you can't have multiple cations and multiple anions, but there's just one type of each. So here we have sodium ions combining with chloride ions in a 1-to-1 ratio, but here we've got barium ions combining with 2 chloride ions. These are still binary ionic compounds because there's only one type of cation and only one type of anion present. And some of these compounds have quite a large number of ions, but they're only of the 2 types. Okay, so that's what makes a binary ionic compound a binary ionic compound. Now you can easily recognize binary ionic compounds from their formulas because their formulas almost always begin with a metal and end with a non-metal. Okay, so we've done a pretty solid discussion of how ionic bonds form, and the formation of ionic bonds, of course, leads to the formation of what we call ionic compounds. Hope you found the video helpful.